Welcome back, Fire 201 students. This is Mr. Clem, and we are going to go over our second time value of money problem. And as we read it here, it says, Mr. Clement offered you a summer job. He said he would either pay you $5,000 at the start of the summer to work all 3 months, or I'd pay you $5,100 at the end of the summer. And the going rank at the local bank is 3% interest compounded monthly, so you got to decide which is a better deal. So one of them, you know the amount of money now, and you want to know what it's going to be in the future. The other option is you're going to know the number in the future, and you want to back it up to today and see which one is better, right? Because they're not the same. If I offered you $5,000 today or $5,000 at the end of the summer, of course the $5,000 today is a much better deal. But these two numbers are not the same. It's $5,000 now or $5,100 at the end of the summer. So let's go to problem number 2 and see how we do some math. So the first problem we're going to deal with is something called present value. Right? So we're going to go back to our slideshow. And present value, again, it's going to be the opposite of what we've been doing. In future value, you know how much you have today, and you want to know what it's going to grow to in the future at a specific rate and over a specific period of time. Present value, we know what the number is going to be in the future. We want to back it up to what it's really worth today. And again, the time matters, and what is the going rate of interest, or what are we comparing it to? What were our alternatives with our money? So in that example, we're getting $5,100 at the end of the summer. We're leaving it in there for 3 months. So we got to take this number, we got to back it up 3 months, and it was compounded monthly. So as we look, we're going to write a formula, and we're going to use PV for present value. Now, all the rest of my formula is going to look really similar. The rate is in the same spot. That's our first option. And per, again, going to be in that second option. Payment is going to be our third option. Now, future value, the number we know in the future, is going to go here in our fourth option. And again, type is either at the beginning or the end. At the end is going to be 0, and that's the one we're going to use. So type is 0, payment 0. Future value in this example is going to be the $5,100. The rate is going to be 3% interest, but it's going to be compounded on a monthly basis. So that's why we're going to take 3% and divide it by 12, take our annual number and turn it into a monthly number. And then the question is, how many months are we going to back it up? How many times are we going to have to back it up? We're going to have to back it up 3 months worth. So what is the present value of something that is at 3% annual interest, compounded monthly, over a 3-month period of time? We put in $5,100. We go ahead and back that math up, and what is that money really worth today? Well, that money is really worth $5,061.94. Take the $5,100 and back it up to today, 5061. Now, we could stop right here and say 5061 is better than $5,000 today. Let's wait and get our $5,100 at the end of the summer. Now, that's just a straight math of it. You may look and go, well, I kind of like my money up now because maybe I've got a better option than 3% interest. That's not part of this problem, but it could be part of what you deal with in a real situation. Or you may go, I don't know that I can wait 3 months to get paid. I'd rather get my 5 now, even though it is less than what it could be, because I need the money now. So again, some of these factors from a personal finance situation are, I get that this is the best option, but waiting 3 months to get paid maybe isn't what I can handle. So we may take the other option, even though we know it's less money. Now, we can do the future value and take the $5,000 and bring it forward to prove it to ourselves. So again, our problem is, well, what if you had $5,000 today at 3% compounded monthly for 3 months? So what is the future value of an annual 3%, but divided by 12, meaning compounded monthly? We're letting it grow for 3 months. No additional money going in, and we're doing it at the end of the month. And the math spits out to be, well, the $5,000 today, fast forwarded 3 months, is only going to be worth 503,759. 503,759 is less than 5,100. So again, getting paid at the end of the summer is the best money option. It's the best option that pays you the most. Now, whether that's something you can, could, or should do, that's a different story. But the 5,100 at the end of the summer is the one that pays you the best or the most amount of money.